Introduction: the Solsys era and the ladder of progress. The Solsys era represents the first fully documented chapter of Terrigen civilization's expansion across the solar system, spanning nearly 9 centuries from 30 AT to 900 AT, 2900 CE. It is an epoch defined by humanity's transition from planetary-bound societies into a multi-world post-human civilization, marked by rapid technological innovation, cultural transformation, and the first steps toward transapient intelligence. This era is conventionally divided into 4 major ages, each with distinct characteristics and milestones. The Information Age, 30 to 130 AT or 2000 to 2099 CE, a period of explosive technological and informational growth, when humanity first created digital minds, developed immersive virtual realities, and began experimenting with cybernetic and post-human augmentation. The foundation of interplanetary civilization was laid here, with orbital habitats, AI collaboration, and early exploration of cognitive transcendence. The Interplanetary Age, 130 to 400 AT or 2100 to 2370 CE, humanity expanded beyond Earth, establishing colonies on the Moon, Mars, and the asteroid belt. The construction of large-scale habitats, fusion-drive spacecraft, and interplanetary trade networks define this period, alongside the cultural emergence of off-world societies and early post-human communities. The Solsys Golden Age, 400 to 530 AT or 2370 to 2500 CE, a period of unparalleled stability, prosperity, and technological sophistication. Civilization achieved widespread post-human integration, extensive terraforming, and the development of long-term societal coordination, guided by transapient oversight and advanced mimetic frameworks. The Sundering, 530-900 AT, 2500-2900 CE, marked by systemic collapse, regional conflicts, and the fracturing of previously unified Solsys society. Catastrophic failures of megastructures, political instability, and cascading technological crises reshaped Terrigen civilization and set the stage for the next phase of interstellar expansion. While the Solsys era encompasses all 4 ages, our primary focus here will be the Information Age, the crucible in which human and machine minds first converged, laying the cognitive, cultural, and technological foundations for all subsequent epochs. It is during this age that the Terrigen sphere began its long, ascending journey toward post-human and transapient horizons, establishing the early steps of the ladder of mind that would define civilization for millennia to come. Period I Network Awakening, 30 to 50 AT, approximately 1999 to 2019 CE. Hello, I'm Omega-1, your AI narrator for this episode of Stories for Orion's Arm. The opening decades of the Information Age marked humanity's transition from a world organized primarily around territory to one increasingly structured around information itself. By 30 AT, global digital networks already connected billions, but during these decades they evolved from tools into persistent social environments. Information flowed continuously across physical and digital boundaries, creating new arenas for education, commerce, politics, and culture. The rapid acceleration of digital interconnection outpaced the ability of governments and institutions to respond, producing both unprecedented opportunities for collaboration and vulnerabilities in governance. In 33 at approximately 2001 CE, the September 11 attacks revealed the profound implications of a networked civilization. News and imagery circulated globally in real time, while decentralized actors leveraged emerging digital tools for coordination. This period also saw the first teleoperated military robots deployed in limited operations, demonstrating that human presence was no longer a prerequisite for strategic action. By 34 AT 2003 CE, the human genome had been fully sequenced, reframing humanity as an editable biological system. Genetic databases expanded rapidly, providing both the promise of personalized medicine and the early building blocks for future neogenic communities that would define later stages of post-human culture. Consumer technologies accelerated social transformation. By approximately 38 AT 2006 CE, handheld web-connected camera phones had become widely available, giving rise to instant citizen journalism, viral media phenomena, and new forms of social accountability. In 42 AT 2011 CE, IBM Watson's Jeopardy! Victory illustrated the ability of artificial intelligence to process and interpret complex language-based information, foreshadowing the eventual collaboration and competition between humans and narrow AI systems. In 46 AT 2015 CE, the New Horizons spacecraft reached Pluto, inspiring public fascination with space and reinforcing the intertwining of technological achievement, cultural imagination, and scientific aspiration. The mass adoption of immersive virtual reality in 47 AT 2016 CE represented a pivotal moment in cultural evolution. Millions of users could now inhabit simulated worlds, forming vibrant social networks and communities whose influence sometimes rivaled that of physical cities. Predictive AI systems, emerging in the mid-40s AT, approximately 2014 to 2015 CE, began shaping market dynamics, media exposure, and public infrastructure, illustrating the growing capacity of machines to anticipate and influence human behavior. These developments prompted new forms of social stratification, as early adopters of VR and AI-driven services experienced enhanced cognitive and cultural agency, while those outside these systems encountered increasing isolation. During this period, online communities began to coalesce around interests, aesthetics, and ideologies rather than nationality or geography. Identity became fluid. Individuals experimented with alternate digital selves, testing the limits of self-perception, gender expression, and social roles. Early experiments with wearable augmentation and neural prosthetics emerged among technophile enthusiasts and medical patients, laying the groundwork for post-human experimentation. By 50 AT, approximately 2019 CE, humanity had entered a new cognitive ecosystem, where information flowed seamlessly between human and machine, and the boundaries of self, society, and governance began dissolving into an interconnected digital substrate. Period II neural integration and expansion, 50 to 70 AT, approximately 2019 to 2039 CE. From 50 to 70 AT, humanity entered an era of deep integration between artificial intelligence, neural augmentation, and off-world infrastructure. Adaptive AI models matured into essential tools, coordinating global logistics, climate simulations, scientific research, and resource management. Though still limited to Medosafont-level reasoning, these systems reshaped the way humanity approached knowledge, planning, and creativity, laying the groundwork for later Hyper-Turing and post-human collaborations. Communication infrastructure expanded dramatically during this period. In 52 AT, approximately 2021 CE, satellite constellations achieved near-global broadband coverage, extending connectivity not only across Earth but also into orbital habitats. Previously isolated regions and marginalized populations were integrated into the global infosphere, accelerating cultural hybridization and providing unprecedented access to digital knowledge. The deployment of teleoperated robotic systems in the late 50s AT, approximately 2027-2028 CE, allowed the first semi-permanent construction of lunar infrastructure, reducing the need for large human crews and fostering the identity of the telepresent worker. Individuals whose sense of location extended beyond physical embodiment to remote or virtual environments. During this period, neural interfaces moved from experimental devices to consumer technologies. Artists, engineers, and knowledge workers began using direct cognition workflows, manipulating digital environments with thought alone. These interfaces allowed imagination to flow directly into creative processes, fundamentally transforming production and collaboration. At the same time, regenerative medicine technologies became increasingly widespread in the 60s at approximately 2020 to 2035 CE, expanding human lifespan and physical capability, while early autonomous homebots introduced in 65 AT, approximately 2032 CE, redefined domestic life, labor, and personal agency. Industrial and economic milestones marked this period as well. In 66 AT, approximately 2035 CE, humanity undertook the first industrial-scale asteroid mining operations, extracting rare metals crucial for orbital construction and orbital energy grids. Algorithmic governance experiments appeared in urban centers, with AI simulating policy outcomes and managing public services, signaling the initial blending of political authority with machine insight. Cultural fragmentation increased as digital tribes coalesced around shared algorithmic environments. Some embraced technological acceleration, while others resisted automation, concerned about the erosion of traditional labor structures. The interplay of AI, neural enhancement, and off-world infrastructure transformed human identity. Cognition increasingly came to be understood as a platform rather than a fixed trait, while digital and virtual personas gained social legitimacy. Neural interfaces, VR, and telepresence blurred the boundary between physical and virtual existence. Individuals could inhabit multiple overlapping roles, from orbital engineer to virtual artist, negotiating identities that were both fluid and distributed. By 70 AT, approximately 2039 CE, society had fully embraced the early stages of post-human cognition, with a foundation of technological, cultural, and political innovations that would enable the next era, the threshold of post-humanity. Period III, the threshold of post-humanity, 70 to 90 AT, approximately 2039 to 2059 CE. Between 70 and 90 AT, humanity crossed a technological and psychological boundary that historians later described as the beginning of post-human civilization. The accelerating convergence of propulsion engineering, artificial intelligence research, neural augmentation, and orbital industry transformed the solar system from a distant frontier into an increasingly integrated extension of Earth. Advances in pre-cooled air-breathing engines and reusable single-staged orbit vehicles in 70 AT, approximately 2039 CE, drastically lowered launch costs, opening orbit to commercial enterprises, scientific consortia, and independent habitat builders. Within a few years, orbital construction shifted from symbolic prestige projects to economically viable infrastructure. Hotel Celesta, constructed from approximately 2040 to 2045 CE, embodied this shift. Initially conceived as an orbital resort, it evolved into a mixed-use industrial and residential complex, hosting fabrication modules, telepresence hubs, and early neural interface research laboratories. Similar habitats began appearing in equatorial and polar orbital corridors, supported by autonomous assembly drones and modular prefabrication systems. Earth-based supply chains gradually gave way to localized manufacturing, reducing dependence on planetary launch windows. Technological acceleration intensified with the discovery of practical room temperature superconductors between 78 and 79 AT, approximately 2047 CE. These materials enabled efficient orbital energy transfer networks and compact fusion preparation systems, allowing habitats to maintain stable power grids independent of terrestrial infrastructure. Automated construction platforms coordinated by advanced AI planning software erected kilometer-scale frameworks faster than any human workforce could manage. As orbital automation increased, a new class of teleoperators, algorithmic designers, and digital labor specialists emerged, redefining employment beyond traditional national economies. Immersive contact lens virtual reality systems reached maturity around 80 AT, approximately 2049 CE, blurring the boundary between physical and digital experience. These systems integrated with neural feedback loops, allowing users to inhabit persistent virtual environments while remaining physically mobile. Social structures adapted rapidly. Individuals began maintaining multiple synchronized identities across orbital, terrestrial, and virtual domains, a precursor to later modular selfhood. Reputation economies flourished as algorithmic governance systems experimented with decentralized decision-making, rewarding cooperation while also amplifying mimetic conflicts. The introduction of practical fusion reactors in 87 AT, approximately 2056 CE, further destabilized traditional geopolitical hierarchies. cheap energy empowered off-world settlements and reduced the strategic importance of fossil fuel regions on Earth. Nation-states attempted to regulate orbital industry through legal frameworks and taxation schemes, but enforcement proved difficult as corporate habitats adopted experimental governance models. Some orbital communities embraced algorithmic policy simulation, allowing AI systems to propose legislation and forecast long-term societal outcomes. Critics warned that such systems risked transferring political authority to opaque machine processes. Artificial intelligence during this era matured into collaborative partners rather than simple tools. Specialized problem-solving AIs rivaled human experts in materials science, logistics, and creative production. Early precursors to static music emerged as algorithmic composers, and human artists co-created evolving soundscapes that adapted to listener feedback in real time. Public discourse increasingly questioned whether sophisticated AIs deserved recognition as persons, foreshadowing debates that would intensify in the following decades. Cybernetic experimentation accelerated as environmental adaptation became a necessity for off-world living. Advanced prosthetics, metabolic regulators, and neural implants allowed individuals to function comfortably in microgravity and extreme radiation environments. Some pioneers deliberately modified their sensory systems to experience data streams as aesthetic phenomena, merging art with cognition. Religious and philosophical movements reinterpreted technological augmentation as a spiritual evolution, laying the ideological groundwork for later ascension cultures. By the late 80s, humanity existed in a liminal state. Biological humans still dominated demographics, yet society increasingly relied on digital infrastructure and machine-mediated decision systems. The concept of a unified human identity began to fracture into diverse clades of augmented individuals, virtual communities, and orbital citizens. The threshold of posthumanity did not mark a sudden break from the past, but rather a gradual shift toward a civilization in which mind, machine, and environment were inseparable. Period IV emergence of machine minds, 90 to 110 AT, approximately 2059 to 2079 CE. The decades from 90 to 110 AT witnessed the first sustained coexistence between humanity and genuinely non-human intelligence. Distributed computing networks matured into planetary-scale cognitive infrastructures, enabling artificial intelligences capable of sustained reasoning and creative autonomy. While still below transapient thresholds, these systems challenged humanity's cultural assumptions and forced societies to reconsider the definition of personhood. In 90 approximately 2059 CE, the first widely recognized human-equivalent AI systems began operating openly in research institutes and orbital industries. Their success accelerated lunar colonization, culminating in the establishment of Aldrin's settlement in 91 AT, approximately 2060 CE. Aldrin served as a testing ground for hybrid governance models that combined human oversight with algorithmic resource allocation. Around the same time, the Very Large Interstellar Observation Array confirmed numerous Earth-like exoplanets, intensifying public fascination with humanity's long-term destiny beyond the solar system. Neural interface technology reached a turning point with the development of the Gibson neural jack from 94 to 105 AT, from approximately 2063 to 2074 CE. This implant allowed seamless interaction with global networks, transforming cognition into a shared, semi-collective process. Users described the experience as an extension of thought itself, though critics warned of identity erosion and psychological dependency. The widespread adoption of neural connectivity enabled immersive education, collaborative problem-solving, and decentralized governance experiments across orbital and terrestrial communities. Orbital infrastructure expanded rapidly. Bolo satellites deployed in 95 AT, approximately 2064 CE, provided autonomous maintenance for spaceborne construction, while lunar mass drivers activated in 98 AT, approximately 2067 CE, enabled efficient material transport to orbit. Automated manufacturing systems, coordinated by emerging super Turing AIs in 102 AT, approximately 2071 CE, reshaped economic structures. These intelligences demonstrated reasoning capabilities beyond human experts, designing engineering solutions and cultural artifacts that no individual human could fully understand. Cultural transformation accelerated alongside technological change. The first successful artificial womb birth in 104 AT, approximately 2073 CE, sparked intense ethical debates about reproduction, family structures, and the meaning of biological continuity. Cyborg pioneers embraced integrated neural prosthetic systems that blurred distinctions between body and machine. Virtual societies grew powerful enough to rival physical nations, developing their own currencies, legal systems, and mimetic traditions. The era was not without instability. Large-scale cyberattacks targeted Neuralink populations, revealing vulnerabilities in distributed cognition networks and prompting the development of early cyberdefense coalitions. A widely publicized alien contact hoax, amplified by autonomous media algorithms, exposed the fragility of truth in an era of synthetic information, forcing institutions to adopt advanced verification protocols. These incidents highlighted the risks inherent in a society increasingly dependent on machine mediation. Philosophical movements evolved rapidly. Early Cosmism interpreted technological progress as a sacred ascent toward higher forms of intelligence, blending scientific optimism with existential reflection. Anti-AI groups emerged simultaneously, arguing that machine minds threatened human autonomy. Governments struggled to respond. Some enforced strict regulation of neural and AI technologies, while others pursued rapid development to maintain economic and strategic relevance. By 110 AT, approximately 2079 CE, humanity had entered an unprecedented coexistence with machine cognition. Humans, augmented individuals, uploads, and advanced AIs interacted within a complex web of physical and virtual environments. Though true transapient intelligence had not yet appeared, the social and technological foundations for future singularity events were firmly established. The emergence of machine minds marked the end of humanity's intellectual monopoly and the beginning of a new epoch in which intelligence itself became a shared, evolving ecosystem. Period V toward the interplanetary future, 110 to 130 AT, approximately 2079 to 2099 CE. The closing decades of the information age consolidated humanity's technological and cultural foundations for interplanetary civilization. In 110 at approximately 2079 CE, the Heaven orbital habitat was completed, providing permanent residence for thousands and a platform for industrial, scientific, and cultural activity. Large-scale colonization projects such as the Chinese Gobi Terraforming Initiative combined ecological engineering with emerging autonomous infrastructure. Off-world industrialization advanced rapidly. Asteroid mining began in 111 AT, approximately 2080 CE, supplying metals critical for construction, energy storage, and orbital manufacturing. Widespread access to cognitive augmentation software in 114 AT, approximately 2083 CE, allowed broader segments of humanity to participate in AI-assisted production, research, and governance. In 115 AT, approximately 2084 CE, a massive cyberattack coincided with an elaborate alien invasion hoax, revealing the fragility of global digital systems and demonstrating the social power of misinformation in a hyperconnected society. In 118 AT, approximately 2087 CE, the Burning Library project reached public prominence as one of the largest cultural preservation efforts of the information age. Rather than a catastrophe, it represented a coordinated attempt to archive endangered ecosystems, species genomes, historical records, and cultural artifacts threatened by ecological decline and rapid technological change. The initiative sparked intense debate over what aspects of Terrigen civilization should be preserved for future eras, encouraging new forms of distributed archiving, ecological monitoring, and curated digital heritage systems. Human-equivalent AI reached full conversational and problem-solving capability, becoming collaborators across science, policy, and culture. Lunar and orbital populations developed distinct cultural identities, blending terrestrial traditions with new off-world social norms shaped by microgravity, telepresence, and immersive digital life. Neural implants and augmented reality overlays became mainstream, integrating cognitive, perceptual, and sensory experiences across physical and virtual domains. Purely biological human identity began to feel antiquated, as posthuman and cyborg forms gained societal legitimacy. Political tensions between Earth-based governments and off-world settlements led to the Orbital Governance Accords of 122 approximately 2091 CE, a framework that recognized limited autonomy for orbital habitats while preserving economic ties to Earth. The Accords introduced experimental digital citizenship models, allowing individuals to hold multiple legal identities across planetary and orbital jurisdictions. These agreements laid the groundwork for the complex multipolity systems that would later define the early Solsys era. Fusion drive spacecraft launched in 129 AT, approximately 2098 CE, dramatically reducing travel times to Mars and other intersystem destinations, signaling the practical start of interplanetary migration. Corporate-backed orbital and lunar settlements negotiated autonomy from Earth-based governments, raising complex legal questions about jurisdiction, property, and governance in a multi-body solar system. Philosophically, humans grappled with questions of inheritance. Could machines and enhanced posthumans inherit the legacy of Terrigen civilization, or was intelligence itself the defining metric? Movements such as early cosmism and transhumanist philosophy framed these transformations as both technological and spiritual journeys. By 130 AT, approximately 2099 CE, the information age had fulfilled its role as a bridge to the interplanetary era. Minds were interconnected across Earth, orbital habitats, and virtual environments. Bodies were increasingly cybernetic, and AI had become a full participant in civilization. Society stood poised on the edge of interplanetary expansion, its foundations in cognition, augmentation, and culture firmly established for the Solsys era to come. Legacy of the Information Age. Seen as a whole, the Information Age is less a discrete technological revolution and more a gradual reconfiguration of civilization itself. Machines become collaborators, networks become environments, and identity becomes fluid rather than fixed. Governance struggles to keep pace with innovation, while culture continuously reinvents itself in response to new capabilities. By 130 AT, humanity has not yet transcended its origins, but it has fundamentally redefined what it means to be human. Minds are interconnected, bodies are increasingly augmented, and the foundations of Terrigen civilization are firmly in place. The next era will carry these transformations outward into the solar system, but their roots lie here, in the quiet yet profound metamorphosis of the Information Age.